Hello, this is physics, and today we talk about relative velocity. An airplane can fly at a speed of 430. The speed of airplane, velocity of airplane is 430 kilometer per hour. And the airplane is flying towards the east. There is wind. The wind is blowing from west to east. Velocity wind. Uh, 90. Wind is also blowing to the east. In other words, the wind is blowing at the rear end, at the tail end of the airplane. Then we want to answer the question, what is the velocity? Or you can use the word speed. What is the speed of airplane when there is wind blowing from behind? Well, from common sense, you will predict that the velocity, because the airplane flies faster, because the wind is helping the airplane to fly forward. So, the plane speed with wind should be 430 plus 90, and it should be 520. Huh? Let's see, where is it? Yeah, you add these two together, then it's 520. And the airplane is flying to the east. Suppose we change the wind direction to the opposite direction. Suppose the wind is not from west to east. Suppose the wind is blowing from east to west. Then what? Okay, I can just change the question a little bit. The wind is, okay, so if velocity of wind only the direction is changed, from east to west, then what is the velocity of the airplane? Again, using our common sense, the wind is against the airplane. Therefore, the airplane speed becomes less. you take the difference, 430 minus 90. Then it is 340. Okay. So this is a simple question. There are certain names associated with this example. If the wind is blowing from behind, we call it tailwind. Tailwind. This case, tailwind. If the wind is flowing against the airplane, then we call headwind. It's this case. Okay. Now, when we say the airplane speed is 430 kilometers, we are talking about the airplane is flying without wind. The wind is not blowing. So the air is still. The air is not moving. So this is what we mean by the speed of, or the velocity of airplane is 430. Without wind blowing. No wind. Then there is a name for that. The speed without wind, we call it air speed. So this speed, we call it air speed. And the speed of wind is easy to understand. It's just the speed of the wind. When you add them together, or when you subtract them, when there is headwind, you subtract, and when there is tailwind, you add. The result we call what? Result we call it ground speed. This is called ground speed. And again, this one is also called the ground speed. The name is quite easily understood because this is the speed if there is a person standing on the ground. And that's the speed which appears to the observer on the ground. Therefore, we call it ground speed. Okay. Let's have more examples. The example we discussed is that the airplane is moving along a straight line. The wind is also blowing along the same straight line, except sometimes using the same direction or in the opposite direction. As long as it's one-dimensional problem. the idea can be expanded to two-dimensional problem. So here is the example. Now, this example, we're talking about a boat. The boat velocity is let's see, 4.5, 4.5 meter per second. And the boat, of course, is going in a river. But the water in the river can flow, right? Yeah. So the speed of water is given. The speed of water is 3.2. Is 3.2 meter per second. Okay. And the water is flowing from west to east. The boat is going to the north exactly to the north. What do we mean by that? We mean the boat, the sailor of the boat aims his boat exactly north. So this is the diagram. The boat is going north. The speed is 4.5. The water is flowing from west to east. Now you look at the diagram. The boat, suppose this is a boat. The boat is going this way, but the water is flowing this way. So the water will push the boat toward the east. But the boat at the same time is going north. Therefore, you push it, it will go like that, you see? Because the boat is this way, the water is pushing this way, then the result, the boat is going this way. Do you follow the idea? Therefore, this is a vector addition. This is the boat, and the water is pushing this way. And the result is the boat is not going exactly north. The boat is not going exactly east. It is going this way. It's a vector addition. All right. Then what do we want to find? We want to find what is the velocity? What is the velocity of the boat as a result of the water in the river is flowing? So we also call this ground velocity, because this is the velocity if there is a person standing on the shore, and this velocity is what appears to the observer on the shore. So we call it ground velocity. What is this? Oh, this is very simple. You add the two vectors, it's Pythagoras theorem. Okay, so this question mark is Pythagoras theorem. So this is how you do it. Because the vector diagram is a right triangle, so you use Pythagoras theorem. So what is the result? Let's see. Okay, so the result is 5.5. So this is 5.5. So 5.5 meter per second. If the question is asking for the ground velocity, okay, we sometimes for simplicity, you can also call it ground speed. But this word speed means not only magnitude, how big, but also in what direction. So it's better to call it ground velocity. What is the ground velocity? So the magnitude is this, then I need this angle, right? The angle tells me the direction. How do you find this angle? This side and this side is the tangent of this theta. So theta is so what is the angle? And use a calculator. You need to use a calculator. So the answer is 35 degrees. So we have the ground velocity of the boat, both magnitude and also direction. 35. How do you write the direction in words, in label? So 35 degrees, this is 35, so it's 35 degrees east of north. Okay, no, it's not this way. You write the direction after the magnitude. So this is the magnitude 5.5. So it is 35 degrees east of north. Okay. You describe the direction after the magnitude. 35 degrees is this. It's on the east side of north. This is north, and it's on the east side of north. Understand? So that's how you write it. And the direction is put inside a square bracket. This is the direction. All right. Okay, so next you can ask how long it takes to go from one side of the river to the other side of the river. You see, the water is going this way. Okay, the water is 3.2. And the boat is going this way. So the water pushes the boat, and actually the ground velocity is this way. Okay, this is 35. So the next question is, how long does it take the boat to go from this point to this point? How long does it take? Remember, the boat starts from here, and here. It doesn't end there because the water pushes it. So this is the starting point This is the end point. So how long does it take to go from here to here? So you can say the time is distance divided by speed, right? So because the boat goes from here to here, you need to find this distance divided by the speed. The speed you already have. Speed is 5.5. The speed here is 5.5. So you need to find the distance here. But there is another way. To find this distance, you need to know the width of the river. What is the width of the river? It should be given, okay? So in this question, it is 220. The width of the river is 220 meters. Because the width is always given this way, perpendicular to the shore. Therefore, why don't we use this distance divided by this speed? Remember, the distance and speed must be in the same direction to get the time. Let me repeat. You can use this distance to divide this speed. Or I can use this distance to divide this speed. But this is easier, right? Because this speed is 4.5. Therefore, the time is, time for crossing is 220 divided by 4.5. Understand? 220 is this way, 4.5 is this way. All right? So the result is 49 seconds. 49 seconds. 49 seconds. Okay, so let me, it's the distance divided by speed is the time. Distance is directly cross, so the speed is directly cross this speed, 4.5, not this 5.5. Understand? Okay. The next question. Since we understand because of the water in the river, the boat is pushed to the east, therefore this is the landing place. The boat will land here, not here. The next question is to find how far is this distance. How far is this distance? How far? And that is easy because the time is 49 seconds and then the speed in this way is the speed of water. Therefore, you multiply the speed of water by the time of crossing, you get this distance. So, the water is flowing this way. So this distance is how far downstream from directly across. This point is directly across, but the landing point is here. So how far downstream is that? How far downstream? Downstream. Downstream is this speed, which is 3.2 times 49. So, what is this? Then the result is 160. So the landing point is 160 meter downstream. Downstream means downstream you are referring to the point directly across. It's 160 meter from the point which is directly across the starting point. Yeah, this is 160. All right. Okay. So there is another question, another part of this same question, another part. So let me erase this. Let me understand the question so far. So the boat is aiming. You set the direction of the boat directly to the north. But the water pushes the boat towards east. Therefore, this is the actual path. This is the actual motion. Suppose the sailor of the boat wants to arrive at the point directly across the starting point. He doesn't want to land somewhere downstream. He doesn't want that. Suppose the sailor of the boat wants to arrive at the point directly across. So he wants to arrive here. How do you do that? Then you cannot aim the boat this way. You should aim the boat that way because the water is pushing this way. So if you aim somehow that way, the water push and you arrive exactly opposite to the starting point. So the diagram should be something like this. You should aim to the west of the landing point. So aim that way. And this is current. This is the water speed, which is 3.2. You aim that way. That means the speed of this is 4.5. And you want this vector plus this vector to be this vector exactly north. So you want this plus that exactly north, which means you want this to be a right angle. The question is, you should aim at what direction, which means what is the theta you want? Let's not use the theta because we already use the label theta, which we use another letter to show that. Alpha. What is the angle alpha? Now we know this side, which is the opposite, and we know this side, which is the hypotenuse. Therefore, the relation is sine, opposite over hypotenuse. So sine alpha is 3.2 divided by 4.5. So alpha is arc sine So what is the answer? The answer is The answer is 45 degrees. The answer is 45 degrees. Use a calculator to get the answer. So, what should be the direction you aim it? So it's if you write the direction, it should be 45 west of north. Understand? The 45 degree, the west side, this is the west side of the north. West side, 45 degrees west of north. Okay. So this ends the problem. Let's have another example. Okay. So this example is that, okay, now we have an airplane. The velocity of the airplane is 215. Okay. And the wind is 57. The wind is blowing toward east. All right. The airplane is flying, in this example, it is not flying directly north. It is flying at an angle 34 degrees okay. The airplane is flying not exactly north at an angle 34 degrees on the east side of north. Then what do we want to find? We want to find the ground speed. What is the ground speed of the airplane? So we again draw a vector diagram. So this is This is 215 and .34 degrees. And the wind is east. .57, okay. So, what is the ground velocity? Again, It is the speed of the airplane plus the wind speed. You add these two vectors. Add these two vectors. Now, this is different from the first example because the vector diagram is not a right triangle. We cannot use Pythagoras theorem. What do we use? We use cosine law. We use cosine law. I know this side, 215. I know this 57. So I need this angle to find the unknown. This is the unknown. So I need this angle. This is 34. So if I draw this, this is 34. But this is 90. So this angle is 90 plus 34. (124 degrees). I know this angle is 124. 124. Then I can use the cosine law to find this side. So this is what? So the question mark is so this is a cosine law now. So you use a calculator to find it. I'm not going to do the detail using a calculator. This is done, and I write down the answer. I'm sure you can do it. Yeah. Use a calculator, you do it. So this is $251. So this is $251. Just use the cosine law. Now, because you want to find the velocity, ground speed means ground velocity, and you need a direction. So in this case, because it is not a right triangle, so how do you find this angle? Then you use sine law. Use sine law. Oops. Sine law. Use sine law. Okay, you want this angle. So how do you label this angle? Or maybe we use theta, we use alpha. Let's use another letter phi. So sine phi over the side, sine phi over side, the side is 57. Equals sine this angle, which is 124, sine over this side, which we already have, 251. So from this equation, everything is known except the phi, so you can find the phi. Use your calculator to find it. Okay. I'm not going to show the details, so the phi is 11 degrees. So this is 11 degrees. Therefore, this answer, you put the angle after it. 11 plus 34 is 45. So it's 45 degrees east of north. Huh? 45, this is 45 degrees east of north. So we have this now. Okay. So this is a second example. So you follow? Do you follow? Okay. One more example. Okay. So one more example is the wind speed is wind speed is 38 the wind velocity is 38 kilometers per hour, and the angle is given, the direction is given. So let's draw that. Okay, this is wind. What else is given? Okay. So you are given the ground speed of the small airplane. The ground speed means the speed when the observer is on the ground. So what is the speed there? It is, let's see now. I didn't. Oh, yeah. The ground speed is 91 . This is kilometer per hour. And 17 degrees. Okay. This is the ground speed of the small plane. So v ground speed. This is the ground speed of an airplane. So you have the ground speed, you have the wind speed. What is the speed of the airplane without wind? If there is no wind, what is the speed of the airplane? So this we call airspeed, right? Airspeed. So we want to find the airspeed. But we know that wind speed plus airspeed should equal to the ground speed. So this plus a vector should equal to this vector. Then we want to find that vector, unknown vector. So this plus what vector is equal to this? You join this. This plus that should equal to this, right? Therefore, my question is, what is this? You understand? My drawing is poor. My hand is trembling. I cannot draw a good straight line. But you as long as you understand it, this plus this should equal to this. And then what is this? This is not a right triangle, therefore you use cosine law. To use cosine law, I know this side, 38, I know this side, 91, so I want to know this angle. Because this is 25, this is 17, I can find this angle. How do I find this angle? First, what is this angle? This angle is 90 minus 25. Once I have this, add 17, I have this. So this is This is 90 minus 25. What is 90 minus 25? It's 65. So 65 plus 17, it is this angle. 65 plus 17 is 82, right? So this is 82 now. So this angle is 82 now. Now I have the cosine law. Okay, this. Again, use your calculator. Okay. I'm not going to show the detail. Okay. You use a calculator to do this part, And the answer is 94. And you want the direction. You need to find the direction from sine law. Okay. Let's see. How do you write the sine law? This. Yeah, you can find this angle. Find this angle. You need to use a letter to indicate the angle. We have used theta, we have used the alpha, we have used phi, therefore let's use beta. This is angle beta. Angle beta. So sine beta. Sine beta over the opposite side, which is this, 91, equals sine this, 82. Over this side, which is a question mark, we already have the question mark, 94. So from this you can find the beta, okay? You can find the beta. I didn't have the answer here. But anyway, I didn't have the answer, which is not important. So once you have the beta there, then you can find the direction. How do you find the direction there? How do you write the direction there? Okay. Look at this. Look at this. Okay. This is beta. I know this beta, right? This is 25. So you draw a horizontal line here now. This 25, so this is 25. Therefore, this angle, this angle, oh, what is this angle? This angle should be beta minus 25. Right? Now you use a calculator to find the beta, angle beta. So I redraw this part. This is beta. You found it. And it's 25 here, 25. Then you draw a horizontal line. This has to be 25 also. Therefore, beta minus 25 is this angle. So you have this angle. Once you have this angle, then you can write the direction. You got it? I didn't have the detail for this question. But anyway, if it's not a right triangle, you use cosine law and sine law to find the magnitude and to find the direction. Okay, so this is what we want to discuss today. I don't know whether you follow this or not. So review today's lecture and let me know if you follow or not. If you have any question, you send me a text message. You send me a text message, and if you like, I send you notes. Notes and practice. Okay. Again, I welcome your message. Send message to this cell phone number, and I can send you notes and practice to your email. Okay. Okay. All right? Yeah. I can also read your work. If you like to work on the practice questions, you can also send me your results, your work, and I check it and I correct it. So all this can be arranged. Just send me a message. Okay, that's all for today. Goodbye. Thank you for watching.